Hi everyone, welcome to DSA Code. Today we are going to solve a classic problem on encryption technique. So we are going to see today how to encrypt a plain text using Caesar cipher technique. This is one of the techniques to encrypt the plain text or the message. So we get a prompt here, like I'll tell you what exactly we are going to do. So we are going to have a shift of the element, and then we are going to shift that and see what the value comes out to be. So here if we have shift of 2, then we are going to shift it twice, and then we get C, D, E, F, G, H. And we have this as a plain text. All right, if you're not aware about what public key cryptography is, this is how it is. I mean, ignore public and private key for now because as we are not concerned about that. I mean, I only want to make you understand that. Okay, let's just see as we are going to learn this topic. So plain text is some text which we are able to understand. We want to encrypt it using the public key. Public key can be something, uh, any key or some secret key which you're using to encrypt the ciphertext. Or this basically, in terms of Caesar cipher, we are going to use some technique to encrypt here, so we don't have a public key. All right. This concept comes when you are using a asymmetric cryptography, and this concept should be eliminated right now. And this also. So we are going to use a formula to encrypt our plain text. This is a plain text formula, and minus for will be minus to decrypt. All right. So as you can see right now, I have something on my screen. So I'm gonna zoom out. I mean, I don't know how to zoom out. 1 second. All right, all right. Yeah, so as you can see right now, we have C as 2, and then we're using 2 as a key, and we are using shift value, and then you're modulusing it to 26, and then whatever value you get, we find a corresponding ciphertext. And that is how you're doing it here also. You're going to minus, see the difference between the two values, and you're going to do the modulus of that, and then you're going to get a plain text. So this is how you're going to solve encryption and decryption in terms of maths. Whereas in terms of solving the problem, solving the problem in Java, we are not concerned about the uh, formula as such, but as we are aware that we should know the basic concept, so we should know this so that it becomes easy for you to understand what I am going to say. So let's get started. I'm going to create a class. I'm going to create a Java file. Caesar cipher. Okay, I should remove this underscore. All right. So let me just write my main class, public class, Caesar. And in this, we are by default going to have public void, public static void main. Okay. And then we are going to have our function which will encrypt. So we can call that encrypt as well. And we are going to have that return type should be, let's say, string, because we are going to return a string in the end. And then what two things we are going to pass as a parameter? See, as I will go to the prompt. So we need two things. We need the key or the value which we are going to change or the plain text, you can say, and then we need the key for how many shifts you want. So we are going to say plain text, and then let's say integer shift. All right. So this much is crystal clear. All right. So now we write string builder. It's just an enhanced version of string. Don't worry, it is nothing else but the string itself. Yeah, but an enhanced version, as I said, is always going to help you. If you want, I can make another video for that. So keeping that apart right now. And then this is it. We created a class, uh, I mean a variable of string builder type. And as we know now, we have to uh, go through a string. So when you go through a string, and you want to check one value by one, then you have to have a for loop for it. This is but obvious. Like I said, array or string, you get a for loop for checking all the elements inside. Checking or changing, you have to use for that. All right. And then I'm gonna say plain text dot length, and then I'm gonna minus plus plus, and then I'm gonna say char current current character equals to plain text dot char. We're going to have I. So we're going to get the current character value. All right. This is how we get the current character value. Just if you don't understand, just mug it up because there is nothing to be explained. I mean, you get the method here, character add, and the character add, you're starting from zero. Zero is nothing but your first element, and then you go at, I mean, you have to, since we are going to use 0 to 25, so we'll have to bring that in form, ASCII value form also. I'll make sure you understand that. First, I'll write character. Character is letter, and then I'm gonna say current char. All right, so we are going to check whether it is a character. Otherwise, a person can also enter a number. So this is it. I mean, I'm just going to create the format because I'm not going to get into the ASCII value before I could explain you. And then after all these things are done, we are going to return the string, so which is going to be the encrypted text. We are going to append that to what exactly is the current value. All right. So I'm gonna say encrypted encrypted text dot appended should be appending it to current char. Okay. Here we actually just do it through string and then we send it. This appending part will be in the part of else part, okay? Because if if the character is not, I mean, if it is a number, then we are not going to change it, right? Because nowhere we have mentioned that We are going to change a number here. I mean, as you can see, we are not having a number in here. We have not defined any key value for that also. So I will say A to Z, A to Z, and it will have ASCII values. Alright. A to Z has ASCII values still 65 to 90. From 65 to 90. Alright. And smaller A to smaller Z, ASCII value comes out to be. I mean, this ASCII value is nothing but uh, ASCII values are just, I mean, American Standard Code for Information Interchange. This is what ASCII stands for. And we are just having keyboards. When you press a button A on your keyboard, there is an ASCII value which is been understood by the computer. So that is what ASCII value is exactly. So we're going to have 65 to 90, and we have 97 to 122. All right. So this is what it is. I mean, so how can we compare two things? Here we have ASCII value, and here we have element values. So, and in the formula also, as you can see, I have key value been getting added to n and not an ASCII value. I mean, as you can know, as you can understand from the concept that there is no for ASCII value been introduced in the formula. So we'll have to minus that. So what am I gonna do there? So I'll have to bring it from 0 to 25, right? So I'll have to do, I'm gonna bring, I'm gonna say the base is going to be, I'm gonna check first if it is uppercase or lowercase. Is upper front cat, and if it is, then I'm gonna say A, or if it is not, then I'm gonna say smaller a. This is a ternary operator, by the way, if we have not talked about it this before. What am I missing now? Cannot convert string to char. All right. While you write something about char, you have to use a single inverted comma and not the double inverted comma. That stands basically that you're defining a string and not a character. All right. And then I'm gonna say int char int shifted char. All right. Will we not do anything for shifted char? Yeah, we'll have to initialize. Shifted char is equals to current char, and then we're gonna minus it with base, and we're gonna plus it with the shift. And then also to compensate, you're gonna do mod to 26, and then we're gonna add it with the base. As you can see in our formula, like we have this formula here. This is the formula, okay? So we are adding, and nothing has been subtracted here. So to bring that to the format of 0 to 25, we are subtracting this base, okay, which is nothing but your uh, element value right now. We're just converting and getting the ASCII value, and then we are minus. We're going to minus, or the difference is going to be uh, giving us a key element, and then key element can be added. This is nothing but your key element, okay, and then we are adding with a shift. And then we're just adding base at the end because we have subtracted here. And then the shift, because we need to again bring it back to the ASCII form. All right. So let's go ahead and say encrypted text dot append current var, and that is it. Now we are good to check now. So let's say we already declared a main function here. I'm gonna say string plain text equals to welcome to DSA, welcome to DSA codes. And I'm gonna say int shift equals to 3. And I'm gonna encrypt it. And I'm gonna store it to encrypted. Alright, so we need to just encrypt it using the function encrypt plain text shifted shift key, and then we get the output as encrypted. So we are going to say original and system dot out dot print encrypted. For this, I'm gonna say original and then I'm gonna say encrypted. And then I'm gonna change it to sorry, this is not encrypted. This is going to be the plain text. This is going to be encrypted. Since we are done now, so let's go ahead and check. So what is the problem? Okay, I'm gonna clear this and then we'll use JavaC compiler. And then I run it. It's running. Maybe I'm not getting the encrypted value. What could be the reason? I mean, original text we are getting encrypted is not coming out. This is plain text. This is shift, plain text shift. What could be the reason for this now? I mean, we should be getting an encrypted value. Uh, we are returning what? To string. We are appending it. Okay. What are we missing exactly, guys? Okay, let's see. Let's just click and see whether it is declared. Okay, so it is appended. All right, so that is not a problem actually. So guys, I have actually solved the issue. So as you can now, I'll just brief you with the code. I mean, like we have actually declared a function encrypt, and we are using that here to encrypt the plain text with a shift. Exactly, that is what we are going to do here. I mean, for us to bring. I mean, I have actually wrote here the comments. I mean, right now because I want you to understand if the character is a letter, then we are just checking if the character is a letter here, and then we are going to check if the character is not a letter. Then we are going to keep it unchanged because I told you that there is no nothing as such in this list called we are nothing having here to replace with in integer values, or you can say numbers. All right, so that is what we're checking. We just keep appending it as it is if here there is nothing. Otherwise, if there is, then we're checking whether it is lower or uppercase, and then according to this, we are bringing them into the ASCII value, and then ASCII value is being added and subtracted. I mean base is removed, so bringing the key value here, and then it is added to the shift, and then again to get the ASCII value, we're adding the base again, and then yeah, in the last video we actually missed something, was this shifted character. So we had to actually append the character which was shifted character. We actually were not appending anything and we were encrypting it. I mean, I missed this part. All right. And then rest of the story is quite simple. We are, just converting it to the string encrypted text, because this is a character. Guys, we are actually going through the plain text in the form of character. All right. We are appending character. So we actually need to bring it into the string format, because it is going to give you something in an array format. So that is what we did. So let's say Java C, then I'm gonna say Java, and then I'm gonna say, instead of hello world, I'm gonna say hello YouTubers. Okay, I'm gonna say Java season cipher. So that is what you get now. So this comes out to be your output, all right. So thank you for watching my video. Please like, comment, subscribe, and share with your friends. And don't forget to share with your friends, and keep yourself updated whatever videos I upload. Thank you so much.